quadratic formula. Some of you did the quadratic formula last year. That's another way. And the third way is by factoring. And you are going to be required to be able to do all three ways. Okay? So this is, we're just looking for where the parabola actually is going to be crossing the x-axis. That's our goal. Okay? So right now, we're not dealing with a function, we're just talking about an expression and we're learning how to deal with it.
But we'll need to do this.
Yes, 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 yes. So I just made a little sketch for you. Would you agree that this is x squared plus 4x's plus 3 units? Okay, and I couldn't turn this figure over, and I just couldn't do it. But if I said to you, well, let's look at how we did this. What are the factors? Where's that problem? What are the factors of 3 whose sum will give us a 4? Okay, so I know I'm always looking for factors whose sum is the middle term. So the factors in this case are pretty easy. It's 1 times 3, and I know that 1x plus 3x equals 4. So look at this. If I said to you, well, let's do the area model, and I had x squared, what goes in that little corner?
3.
The 3, okay, and then what goes into the other 2 boxes?
3x.
All right, 3x and 1x, okay? Is everybody good with that? Well, what we're trying to do is create a rectangle. So what do we have here? What is the common factor? X. And what do we have? This is 3x, isn't it? What is the common factor here?
3.
3. So x times what will give me x squared?
X.
X. X times what will give me 1x? 1. How about, this is, actually, do you mind if I switch this over so that it matches my model? I'm just going to put the 1x here and the 3x here. So x times, this is going to be what, 3? And what do they have in common here? And this is a common mistake that people make right here. But do 1 and 3 have in common? 1, good.
Why?
Because they don't see that they both have a 1 in common. The factors of 1 are 1 times 1, and the factors of 3 is 1 times 3. They have a 1 in common. People make a mistake, and they forget that. Okay? So in this case, I have x plus 1, and this one is x plus 3. Well, in this model, isn't this x squared plus 4x's plus 3 units? What I wanted to do was flip this over, which I couldn't do. Isn't this x times x is x squared? X times what will give me the 3x's? X times 3. And this is going to be 1 times x gives me 1x. And 1 times 3 gives me, if this was, I'm going to just sketch that.
Why is that turned sideways?
Because I used a geometer sketch pad as a drawing tool, and I just couldn't, it wasn't working, and I didn't have more time for me to figure out why that particular one, because I was able to get the others to rotate. Okay, so it's just a technical difficulty that I ran into. Okay, so do you see, when I'm saying the area model, does that make sense to you? That I'm using actual tiles to do this multiplication? Okay, does anybody have any questions? Does that make sense to you? Yes, no, maybe? Okay, that's how I'm getting this area, and I'm not asking you to draw tiles, but we're just drawing a box. This times this gave me x squared. X times 3 gave me 3x's. 1 times x gave me 1x, and 1 times 3 gave me 3 units. Okay? All right, I'll give you another one to try. Oh, this one actually is pretty easy. All right, how about if I did x squared plus 3x plus 2, What are the factors that will work?
2 and 1.
Yeah, 2 and 1.
So if there are no factors that add up, it doesn't simplify any further.
This is going to be 2x plus 1x, right? So if I do my box, I'm going to have x squared. What goes in this corner?
2.
The 2. And what are the other things that are going in here?
2x.
2x and 1x. Greatest common factor? X. X times what is x squared? X times what is 1x? 1. What times x is 2x?
2.
And 2 times 1 is 2. So my factors are x plus 1 and x plus 2. X plus 1 and x plus 2. Do you agree with that?
Yeah.
And if I showed you the drawing, does that work? There are, I can put it over here. So here is x squared plus 3x's plus 2. And what we're trying, the area model, I can only use that if I have a rectangle or a square. Okay, and that's what we're always going to be doing, either making a rectangle or a square. We're going to be doing something next week called completing the square, which is, that's why I'm taking the time to make sure that you understand this, because once you understand the idea of this rectangle, making it into a square will make sense to you. Okay, anybody have any questions on that? All right, so then, why don't you open up your packet